In example 7, we've got a function f of x, which is 4x squared minus 8x plus 3. And in part A, we're asked to find the gradient of that curve at a particular point. So I'm going to need to know the gradient function. So I'm going to differentiate my expression, which is going to give me 8x minus 8. That's the gradient function. It tells me the gradient at any value of x. And I want to know the gradient when x is a half. So when x is a half, the gradient function has a value of 8 times a half minus 8. So that gives me an answer of minus 4. So the gradient at the point 0, at the point a half comma 0 is minus 4. Right, part B. Find the coordinates of the point on the graph where the gradient is 8. Right, well, this is the gradient function here. And so I want to know what value of x gives me a gradient of 8. So what value of x makes the gradient function equal 8? So I'm going to solve that equation. Plus 8 to both sides. And lo and behold, when x is 2, the gradient is 8. And it wants to know the coordinates of the point. So I know that x is 2. So what will y be at that point? Well, y is 4x squared minus 8x plus 3. And x is 2. So that's going to be 4 4 is 16 minus 16 plus 3, which gives me a y coordinate of 3. So the point in question is the point 2, 3. That's the point at which the curve has a gradient of 8. Right, part C. Find the gradient of y equals fx at the points where the curve meets this line. Well, you better work out where the curve meets that line. So the curve itself is 4x squared minus 8x plus 3. And we want to know where the curve equals this line. So let's find out what x values give us the same y coordinate. Solve that equation. That's going to be, that's a quadratic equation. Let's set it equals 0, minus 4x from both sides, plus 5 to both sides. Right, so I've got to solve that quadratic. Divide everything by 4. X squared minus 3x plus 2 equals 0. Can I factorize that? Bet I can. Okay, so I'm looking at minus 1 and minus 2 there. So that gives me solutions of x equals 1 or x equals 2. So those are the x coordinates of the points where the curve meets the line. Okay, and I'm asked to find the gradient at those points. So I don't actually need to find the y coordinate at those points. I just need to find the gradient at those points. Well, here's the gradient function. Gradient function is f dash of x equals 8x minus 8. So when x is 1, the gradient equals 8 minus 8, 0. And when x is 2, the gradient is 8 times 2 minus 8. The gradient is 8, isn't it? So let's just check I've answered the question correctly. Find the gradient of y equals f of x at the points where the curve meets the line. There we are, so those are my two answers. So that is example 7 complete.